the activity about drug adulterants, and I will be introducing you the equipment and apparatus we will be using for this activity. Number one, of course, it is necessary to have the microscope as our equipment, and come here, and the baby powder, the measuring tape rather. We have two right here, and then the paracetamol or the crystal, and then here's the wipes and dropper. The dropper, it is used to measure the liquid we will be using, and then this is the mortar and pestle. The mortar and pestle, this is the evaporating dish. It is used to hold our specimen, and this one is the magnifying glass, to magnify the specimen, of course. And then this is the methanol, and well, this is the ethanol. And this one is the distilled water, and this is the hydrochloric acid, which is we will be using to mix it with our specimen, to dissolve the specimen. And this one is this funnel rather, is used to measure the liquid for us for it not to be spilled out. So it has 75, if I am not mistaken. This is the Erlenmeyer flask, which has 50 ml, that can measure 50 ml liquid. And this one is a beaker, which contains 100 ml. This one is also a beaker, which has 400 ml. And before I forgot, we would like to introduce you to the goggles. It is used to protect your eyes.
For the first step of our experiment, we began by preparing the liquids that would be used for testing the different adulterants. These liquids were needed for the mixing process and for observing how the substances react when combined with different solvents. During this part of the procedure, my groupmate was the one who carefully poured the liquids into the laboratory glassware. He placed the liquids into the beaker and the Erlenmeyer flask, which are commonly used containers in laboratory experiments for holding and mixing solutions. While he was doing the pouring, I was the one giving instructions and explaining the procedure to the group. I guided him on what needed to be done and made sure that the liquids were placed properly into the correct containers. I also explained the purpose of preparing these liquids, since they would later be mixed with the adulterant samples to observe their physical changes and reactions. The beaker was used to temporarily hold some of the liquids, while the Erlenmeyer flask helped contain the solution in a table container that is suitable for mixing. By preparing the liquids in advance, we ensured that all the materials were ready for the next step of the experiment. After the liquids were properly placed into the beaker and the Erlenmeyer flask, we were able to proceed with the preparation of the adulterant samples and continue with the rest of the activity. In this part of the experiment, we prepared the solid adulterant samples that needed to be crushed before they could be used. In this video, we were crushing the mint candy and the stone crystal, also known as tawas or alum. Since both of the substances were in hard solid form, it was necessary to crush them into smaller particles. Crushing the samples helps them easier to mix with the different liquids and also allow us to observe their characteristics more clearly during the experiment. And then we carefully crush the mint candy and the tawas crystal until they became fine particles. Breaking them into smaller pieces helps to increase the surface area of the substances, which makes it easier for them to interact with the liquids that will be added later in the procedure. After crushing the mint candy and the tawas crystal, the powdered samples were then ready to be placed into the evaporating dish for the next step of the experiment, which involved mixing them with different solvents and observing the changes in their appearance. So here it is now, the tawas with distilled water. When tawas is mixed with distilled water, the crystals gradually dissolved, producing a clear and colorless solution once the solid has fully dissolved. And for the next observation, tawas with methanol. When tawas crystals are mixed with methanol, the crystals dissolve slowly or remain partially undissolved. The mixtures may appear slightly cloudy if small particles remain suspended. In a third observation for tawas with ethanol, when mixed with ethanol, tawas crystals may dissolve very slowly. Some crystals may remain visible at the bottom, while the liquid stays most clear. In our observation for tawas with hydrochloric acid, when tawas is mixed with hydrochloric acid, the crystals may dissolve in the acidic solution, forming a clear liquid with no visible solid particles if fully dissolved. Next adulterant is snowbird candy with distilled water. When snowbird candy is mixed with distilled water, the sugar dissolves easily, forming a clear solution. The solid particles gradually disappear as they dissolve in the liquid. Snowbird candy with methanol. When crushed snowbird candy is mixed with methanol, the sugar begins to slowly dissolve, creating a clear to slightly cloudy liquid depending on the amount of sugar present. and a snowbird candy with ethanol. When mixed with ethanol, the crushed candy dissolves more slowly compared to water. Some particles may remain visible while others dissolve, making the mixtures appear slightly cloudy at first before becoming clear. Forward for the snowbird candy with hydrochloric acid. When mixed with hydrochloric acid, the sugar also dissolves into the liquid, producing a clear solution if the sugar is completely dissolved. In this part of the experiment, I tried to observe if there was any differences in the odor of each adulterant sample. I carefully smelled each substance one by one to identify whether they had a distinct or noticeable smell. While doing this step, I made sure to smell the samples carefully and not inhale them directly in large amount for safety. Baby powder with distilled water. When baby powder is mixed with distilled water, the powder creates a white cloudy suspension. The powder does not dissolve and may clump together or float, while some particles gradually settle after standing. Baby powder with methanol. When baby powder is mixed with methanol, the powder does not dissolve. Instead, it forms a cloudy mixture where the fine particles float temporarily in the liquid. After a few moments, some of the powder may settle at the bottom, while the liquid above remains slightly cloudy. Baby powder with ethanol. When baby powder is mixed with ethanol, the powder remains undissolved. The textures appear milky or cloudy, and the particles may float for a short time before slowly settling at the bottom of the container. Baby powder with hydrochloric acid. When baby powder is mixed with hydrochloric acid, the powder still does not dissolve easily. The mixture appears cloudy, and the particles remain suspended or settle slowly at the bottom. Also smelled the sample to check if there was a difference in odor compared to the first adulterant that we tested. When paracetamol is mixed with the salt water, the powder does not dissolve completely. Some particles remain suspended, giving the mixture a slightly cloudy appearance, while other particles settle at the bottom. When paracetamol powder is mixed with methanol, some of the powder partially dissolve, while the rest remains suspended in the liquid. The mixture appears slightly cloudy. Paracetamol and ethanol. When mixed with ethanol, paracetamol partially dissolve, but some particles remain visible. The mixtures appear slightly cloudy or contain small suspended particles. When paracetamol is mixed with hydrochloric acid, some of the particles partially dissolve or disperse, making the mixture appear slightly cloudy or containing small particles. Under the microscope, baby powder appears as very fine, colorless particles. The particles are usually irregular, plate-like, and layered because baby powder commonly contains talc. These thin flakes may overlap with each other, creating a smooth, powdery texture. Baby powder with methanol. When methanol is added, the baby powder does not dissolve because the talc is insoluble in alcohol. Under the microscope, the particles remain visible and separate slightly as the liquid spreads them across the slide. Baby powder with ethanol. The baby powder particles also remain undissolved. The liquid disperses the particles, making them appear more spread out and suspended in the solution. Baby powder with distilled water. When distilled water is added, the baby powder forms a cloudy suspension. The particles do not dissolve and may appear floating or slowly settling while still maintaining their flake-like structure under the microscope. Baby powder with hydrochloric acid. When hydrochloric acid is added, there is usually no strong visible reaction with talc particles. The particles remain visible and mostly unchanged, although they appear slightly more separated in the liquid medium. Under the microscope, crushed snowbird candy shows sugar crystals. These crystals are transparent or slightly white, with sharp edges and geometric shapes, which are typical characteristics of sucrose crystals. When methanol is added, some sugar crystals partially dissolved. Under the microscope, the crystals appear smaller or less defined as the solvent begins dissolving their edges. For candy with ethanol, sugar crystals dissolve slowly. The crystals appear visible under the microscope, but they become less compact and more dispersed in the liquid. When distilled water is added, sugar dissolves easily. Under the microscope, the crystals gradually disappear as they dissolve, forming clear solution. Snowbird candy with hydrochloric acid is when it's added, the sugar crystals dissolve in the acidic liquid, and the sharp crystal shapes become less visible as they break down and dispersed. Under the microscope, tawas appears as clear crystalline particles. These crystals often have symmetrical shapes and smooth surface, giving them a glass-like appearance. Tawas with methanol. When methanol is added, tawas crystals partially dissolved, causing the crystal edges to appear less sharp and slightly blurred under the microscope. Tawas with ethanol, the crystals dissolve slowly, or it remains partially visible. The particles appear more scattered due to the liquid medium. Tawas with distilled water. When distilled water is added, tawas dissolves more easily. Under the microscope, the crystals gradually shrink or disappear as they dissolve in the water. Tawas with hydrochloric acid. When hydrochloric acid is added, the crystals dissolve faster due to the acidic environment, causing the crystal structures to break down and become less visible. Paracetamol. Under the microscope, paracetamol powder appears as small crystalline particles. These crystals may look needle-like or plate-like depending on how the compound crystallized. Paracetamol with ethanol appear partially dissolved, causing the crystals to appear smaller and less defined under the microscope. Paracetamol with ethanol. Paracetamol crystals also partially dissolve. The particles appear more dispersed and slightly reduced in size. Paracetamol with distilled water. When distilled water is added, paracetamol has limited solubility, so many crystals remain visible. Some particles partially dissolve while others remain suspended. Paracetamol with hydrochloric acid. When hydrochloric acid is added, the particles break apart or dissolve slightly, causing the crystalline structures to become less distinct under the microscope.